Hello everyone, welcome to today's session. We are going to continue our discussion on Python data structures. So we have seen list and some introduction to tuples, and again we are going to continue our discussion on tuple, and then I will continue with sets and dictionaries. Let me share the screen. So as we know, tuple is immutable. We cannot change the values. So let's see how do we operate on tuples. So we can create a single element tuple like this. T is equal to observe the parenthesis 5 comma. Let it connect to console. Print T. See, this is a single element tuple, and rest was see. Well, to create a tuple, we can do packing. So we can even try. Just let's take some suggestions from our beloved Gemini. So I don't see though here. Yeah. So tuple packing, which is the process of putting multiple values into a single tuple. So we just can include like this. A packet tuple is equal to a comma b comma c. What we need to do? We just need to mention the element separated by comma. Okay. So that's it. So T1 is equal to 4 comma 5 comma 6. Okay. Print type of T1. See, it's a tuple. By default, these elements 4, 5, 6 are packed into tuple. So that is why we call it tuple and tuple packing. Okay. So tuple unpacking is the process of extracting values from the tuple. Okay. So if I want to extract, that means I just use the tuple name, isn't it? So then all these complexities, let's just. So we can assign the elements to the corresponding number of variables on the left side of an assignment operator. So Python matches the elements in the tuple to the variables in the order. So for example, if I want to have the tuple here, coordinates is equal to 10, comma 20, and now I need to unpack it to the other variables. I know already there are two elements inside this tuple, so I need to unpack it to the two variables x and y. So x comma y, I just unpack it in that. I have t2 is equal to 2 comma 3. It's a tuple. Okay. So now I know that there are two elements. So I'll just assign it to two variables x comma y is equal to t2. Print x comma y. See, 2 and 3 are unpacked to x comma y values. So this is unpacking of the tuple. Okay. So that is one operation involved with tuple. So let's see the indexing works. How do we access the elements in the similar way to list? Indexing also works here. So just simply print t1 of 0, c1. So indexing is also same, and print t1 of negative 2. Just guess it. -1, -2, right? 4. So same. Indexing is same as list. So slicing also, we have done indexing, slicing with the help of indexing. So just take it two index 1 to 2 or 1 to 3. So I get 1 and 2. I mean the first and the second values. So I just need to mention T1 of, see, T1 of 1 to 3. It starts from 1, which is 2, and it ends at 2, which is 3. So 2 and 3 are the values in the output, which is slicing, which I've already explained it once. And count and membership and all are same. Length, I think we can discuss because that is something special. Length of T1, which gives me the number of elements present here actually. So T1, how many elements are there? One, two, three, four, 5 elements, right? So length of a particular tuple or length of a particular list gives you the total number of elements present inside the list or the tuple. So that is about length. Concatenate also works in the same way as list. And the for loop and the enumerate and how do we unpack it, all are same actually. I can create nested tuples also like this. So this is tuple inside tuple. I can create nested tuple also. And to access the nested tuples, okay, if I mention t of 0, for example, observe here, this is having the first index, but in the first, in the zeroth index, you have two elements, 1 and 2, right? In the first index, we have 3 and 4, the two elements. So that's why zeroth will have two elements. Inside that, zeroth will be 1 and first will be 2. So double indexing would work here. Zeroth, in the zeroth index, fetch zeroth one, which is 1, right? See, 1. I want to access zeroth element, which is this, and the first in that it is 2. In this way, we can access the nested tuples using double indexing. And if I want to convert a list into the tuple or tuple into the list, simple thing I need to do, you know, list one is equal to list of or list function. Okay. If I want to convert from list to tuple, tuple is the function. If I want to convert from tuple to list, list is the function. So list of t, simple. So now I'm printing list one. So which is nothing but, see, t was this. Now it has converted to list. So 1, comma 2, 3, comma 4 are inside the list. So that's using conversion methods. And actually, this could be good. Maximum, minimum, sum, any, and all. So let's see. Let's create one more tuple. Okay, the better values. Okay. So now I need to print max of T1. Okay. So which provides you the maximum value present inside the tuple. Okay. And similarly, the minimum also, min of T1 provides you the minimum element present in the tuple. And sum of T, so it just adds all the elements together and gives you the sum. Any actually checks if the elements are inside the tuple. Okay, so we don't use it in this way. All also it's used for checking. So I cannot assign or I cannot modify the elements of the tuple. As you already know, it is immutable. So let's go to set. Okay. So this is a brief of tuple. So sets actually, it is an unordered collection and it stores unique elements. That's the speciality. Every data structure has its own speciality in Python. So a set here, it stores only unique elements. Even if you store duplicates, it won't allow that. It removes it by default. Okay. And it can change the values in the course of a program, which is mutable. and you can write it using curly braces. So if I want to define set one, I have to start with curly braces, 2, 3, 4, 5, then print set one. Okay, fine, cool. But if I just repeat it by chance, still the repeated elements are not here, isn't it? So that is the speciality. Even if you duplicate, even if you repeat the elements, it won't come up in the set. So set by default, it removes all the duplicates. So whenever you have a data structure like list tuple, okay, they have duplicates. So you need to convert or you need to remove the duplicates present in list and tuple. The shortest method here is to convert it into set. Once you convert it into set, all the duplicates are gone, and then you can convert back to list or tuple if you want it for more operations. So that is the shortest method, and it can be asked in the interview also. So how do you remove duplicates, or how do you make sure you have unique elements inside a data structure in Python? You can just answer, we are just creating a set here, or if you have any other data structure, we'll convert it into set so that only unique values are present in our data structure. So that's how we created. And if I want to create an empty set, I can create it this way. Okay. Properties, it is mutable and it doesn't allow duplicates, and we can do union, intersection, set operations. So we can't access using this square parenthesis like we did for tuple and list. We cannot access in this way. We just need to use loop. Okay, for example, I have set one here, right? And if I print set one of 0, I get error. Set object is not subscriptable. So I cannot use those subscripts here in set. So what's the option? We need to use loops. Just a second. For I in set 1, print I. So now I can access all the elements of the set 1. Okay. 1, 2, 3, 4, 5. So you can add element using add function. So set 1 dot add 9, print set 1. See, 9 is added in the end. And I want to add multiple elements. I can use update. Sorry. I can give a list of values in order to add. Okay. See, these are all added in the end. And I want to remove, I can use remove function also. Set 1 dot remove. I just mentioned 11. So 11 is removed. And similarly, pop, clear, discard works all the same to remove the elements. So if element is not present, remove throws the error. But instead of using remove, we can use discard. And all the operations are really, really important. And that's why sets are very famous, right? You know, the sets in usual mathematics also. We did the union operation, the intersection operation, difference, or left joins or right joins. We did it with the help of sets. We will declare two sets here in order to show those operations. Yeah, yeah. So let's do this union operation in the beginning. Union operation, what it does, it combines all the elements. Okay. So, just a minute. Yeah. So union operation here, it combines both the sets. So if some elements are present in set one and if some elements are present in set two, and if are performing union operation, then it just can, just combine all the elements. Simple. And the intersection gives you the elements which are common to both the sets. Intersection. See, so here if you observe these two sets, which are the elements common here, 4 and 5 are present in both the sets. So that is how we are getting intersection values. And the difference actually, see, with the difference, how do we mention? Which are A minus B. Okay, if we have two sets, A minus B, I want to do A minus B. So in this case, we get the elements which are present in A and which are not present in B. Okay, so you understood, right? So A minus B, we get the elements which are only present in A and we don't get the elements which are present in B. So for example, set 1 different set 2. So this is usually how, what is it? Set 1 minus set 2. So set 1, we know that it has 1, 2, 3, 4, 5, and set 2 is 4, 5, 6, 7, 8. So here, which are all the elements which are present in only set 1? 1, 2, and 3, right? Because they are not present in set 2. And that should be the output. We want that, and we cannot include this common elements 4 and 5, and we cannot include the elements present in the set 2 or the B. So here we can only include the elements which are present just in set 1 and not in common, not common to both the sets. So that is how we get difference, and we can reverse it. Set 2 minus set 1. This will be vice versa. So we get all the elements present in set 2, just in set 2, except the common elements. So 4 and 5 are omitted, and 6, 7, 8 would be the output. Yeah, so 8, 6, 7. So let's quickly see what is a dictionary. Okay. So a dictionary is super, super important because we have something like key value pairs. For example, you imagine you had a pair of data. For example, you go to the library, you see which book name you want to find. Once you understand the name of the book you're finding, then only you will get the book. Similarly, there will be a lot of scenarios in real world where you need to pair up. So for particular keys, you'll be having the values. For example, in Excel sheet, you have column names and there will be values present in each columns, right? So column names will be student names, student marks, and the school of the students, for example. So each values under the column will be student names, right? It can be Bharat, um, it can be Sharbari, or it can be Lakshmi. So it can be any student name. And then that is that's how you store the values in the Excel. So you need a column name and you need the values. Similarly, in real life, whenever you want to combine two values, pair up two values, keys and values. So this name, age, and course, what you see here, they are the key values. So and these Bharat 20 and AI, they are the actual values. So that's how we create a data structure in Python wherein key and value both are present. So that is nothing but dictionary in Python. Okay. So how do we do it? We just have to make sure the keys we are declaring here, they should be unique, they cannot be repeated. Values can be repeated, so keys here should be unique, cannot be repeated. So we always use this using we always use dictionaries and access the dictionaries using key values. I mean, we don't use the indexing which we did in tuple and list. We don't use indexing in dictionary. We use key and value pairs in order to access. Let's create a dictionary. Simple. So dict1 is a dictionary name, and this is the flower parenthesis. One is a key and colon a. So for this key, a is the value, comma. And for this two, b is the value. And for this three, c is the value. So this is how key value pairs are declared. So this is how my dictionary looks. So I need to access a particular value, and maybe I need to access this B. So how do I do? With the help of a key, right? So print dict1 of 2, B. See, dict1 of 2 will be B. So this is how we use accessing. We can use get method also in order to get the value of the particular key. So we can just print dict1 dot get 3. C, which is the value associated with key 3, which is C. That is what we got using get method or using this accessing. You can do both. Update the element. Dictionaries are mutable. We can change the values of the dictionary. So I need to update the value. I just mentioned the key value, and then I can assign a new value here using the simple assignment operator. See, for 2, it was B earlier, but now I've changed the value. And I can even add another value. So dict1 of 9, for example, is equal to some p. Print dict1. Okay. See, 9 is added in the end. The key and the value associated with this both are added. I can even update, or I can change the existing key value. I can do that. So remove again using pop, and clear empties the dictionary. Delete deletes the key. Let's use pop dict1 dot pop 9. I want to remove this p. Right? I want to remove 9 key and p value. So now let's print dict1. See, that's removed. Yeah, and these methods are really important. Okay, keys and values, items. Okay, we have seen that get and update, pop and clear. So let's just do clear once. Dict1 dot clear removes the dictionary completely. Empty dictionary is there. And if I use delete dict1, entire memory, entire structure gets deleted if I use delete command as it was in the list. And now let's again create the dictionary. Let's use keys. Name of the dictionary dot keys will give you all the keys present in the dictionary. Simple. See, one, two, three are the keys present in this dictionary. And in the similar way, values give us all the values present in the dictionary, which are A, B, and C. Simple. Dot items are really, really important because it gives both keys and value pairs. See, if I want to access both keys and value pairs, I'll be using items. Length of the dictionary, same. Three elements, three key value pairs are there. So that's it about the simple overview of all the data structures. So we'll continue the rest of the topics tomorrow's session. Thank you so much for listening. Thanks a lot. Have a great day. Bye bye.